In this video, we're going to be taking a look at three different one-dimensional collisions using the conservation of momentum. And with the conservation of momentum, we're basically saying that the total momentum before the collision equals the total momentum after the collision. And the only formula we're using is momentum equals mass times velocity. Now that's a pretty simple formula, but you want to make sure that you're very organized with your setup because there's a lot of details in these different kinds of problems. All right, so I have three different pictures here. I'm going to start off with this one right over here, where we have two objects that are colliding with one another that separate after the collision. Now, what you want to do is you want to read the word problem and you want to draw a picture very, very similar to what I have on the page. You want to have both of the objects before the collision, and then to the right of that, you want to have both of the objects after the collision. What you want to do is you want to put the masses that relate to the object right on it, and you want to put the velocities right next to the object with arrows pointing to the right or left. Now, what you want to do is identify what you want to call positive and what you want to call negative. And for this problem and all the rest of them, everything to the right is going to be positive and anything to the left is negative. So if I see any arrows to the left, I'm going to make sure I put a negative sign next to it. So I drew out everything. I have my 3 meters per second, my 0.5, and my 0.25. It doesn't look like I have anything to the left, so I'm going to leave them all positive. Now, all I'm going to do is put an equal sign right in the middle because I know the total of the momentum before the collision equals the momentum after. And then I'm going to drop my MVs straight down. So here's my MV for the red ball. Here's my MV for the blue one. And then same thing on the other side. Now, it doesn't matter what you're solving for. Typically, you're going to have one unknown variable, so whether that's a velocity or mass before the collision or after, you lay out everything just as I did there with the diagrams and the numbers, and it just takes a little bit of algebra from there. So we can take these two and combine them, which gives us 1 kilogram meter per second. We have 1 times 3, which is 3, plus 2 times this initial velocity over here. If we subtract 3 from both sides, then this side becomes -2. And then if you divide both sides by 2, then we have an initial velocity of -1 meter per second, which means that this original object was moving to the left at 1 meter per second. That's why it's considered negative. So in a problem, if you're solving for a velocity, oftentimes people might be concerned which way it's going, but the actual result itself will tell you the direction, because if it comes out positive, that means it's moving to the right. And if it comes out negative, that means it's moving to the left. Now for our second problem, we have something like an inelastic collision where we have an object colliding with something at rest, and then the two combine with one another to have a combined velocity of some sort. Now the trick is you're still doing MVs for everything before and after with an equal sign right in the middle, but if things are physically combined, you can combine them mathematically. So these are physically combined, so since these masses are physically combined, we can combine them mathematically with our masses. 1 plus 2 for the mass, and they're going to have the same velocity because they're connected and traveling together. And then these ones have their own separate MV because they are physically separated. Now this entire side over here is going to have a momentum of 5 kilogram meters per second. 1 plus 2 is 3 times VF, divide both sides by 3. And then we have our final answer of 5/3 for our VF. Now for our last one, we have something that might be called an explosion collision because we have two objects that are traveling together and then they separate afterwards. If I'm taking a look at this one, I do see an arrow to the left. So when I put in that 2 meters per second to the left, I would put in the negative sign immediately after so I don't forget that negative sign. And just like our inelastic collision where the two things connected, this one begins with the two things connected to each other. So we solve for an initial velocity so far, a final velocity, and now a mass. Now, no matter what variable you're using the same technique, which is drawing your picture, making sure everything is labeled, and having a before and after. Now we have both of these masses combined, which is 1 plus our unknown times our v of 4 meters per second. And then that equals the momentum of both things after. So we have 1 times negative 2 plus 6 times m. So what we're going to do here is we can distribute this 4, which would give us 4 plus 4m. 1 times negative 2 is negative 2 plus 6m. And we can combine two things simultaneously, or not combine two things, but do two steps algebraically. I'm going to add 2 to both sides, which would get rid of this, and then turn this 4 into a 6. And then I'm going to subtract 4m from both sides, which would cancel this. And then if I subtract 4m from 6m, that would give me 2m. So then if I divide both sides by 2, that gives us our final answer. And then our mass comes out to be 6 divided by 2, which is 3 kilograms. So no matter what kind of problem you have, solving for a velocity before or after, or some kind of mass, you're going to use the same concept, which is just drawing a good picture with everything labeled right next to it, having a before and after, making sure you're careful about those negatives if anything is going to the left. And if things are physically combined, then go ahead and mathematically combine those masses together and give them one common v for them traveling together, which we did over here after the collision and over here before the collision. Work out a little bit algebra and then solve for unknown variable. So I hope that was helpful in helping you understand and solve 1D collision problems. Thank you for watching and listening.